Well, welcome everyone. I'm Joan Giner, and today we're going to present a tool for describing machine learning datasets. This tool is work developed together with Abel Gomez and Jordi Cabot. We are from the Open University of Catalonia in Barcelona. So first, let's motivate our tool, or which is the background of our tool. There's recent interest in a data-centric cultural shift in the machine learning community. And what does mean? This means that the community is trying to build better data to have powerful machine learning applications. It's simple, but, and there is always a but, data is also the source of troubles. Let me show you a couple of examples to illustrate this kind of troubles that may lead to machine learning model. The first one, it's bias in facial analysis. It's a widely known case in the research literature, and is a data set with fewer dark faces could generate a bias in a facial detection machine learning model. And therefore could generate a bias for a specific social group, raising an ethical issue. Far away from ethical issues, another example to illustrate these troubles are a data set gathered from Australian speakers could drop the accuracy of a language model intended to work for US citizens. And this is due to diversity in language styles. And this example happens in English, but also could happen with Spanish from Latin America and Spanish from Spain. In both cases, we see the need to know more information about data. For instance, the first one, in bias in facial analysis, we need to know a high-level analysis of which social groups are involved in this data set. And you will think, maybe it's easy, because there's an attribute called race. No, it will show us which is the race of the people in the data set. But there are a lot of examples that it's not simple to know, or not obvious to know which groups are involved in a data set. In the second example, we need to know more information to use this data set. For instance, we need to know provenance information, how the data was gathered. We know that the data was gathered in Australia only for Australian speakers. Maybe we don't use it if our model is intended to work for US citizens. Okay. And what's the conclusion of these troubles? That we need to better annotate data sets. And it is a widely known idea in the community. And the machine learning community is proposing general guidelines to document data sets. Sounds familiar to us, this kind of documentation in assets. But, and there is always a but, these general guidelines that tells to us what has to be annotated or how we can document datasets are based in natural language and have limitations and are hard to compute. So here comes our proposal. We propose a domain-specific language to describe datasets for machine learning. And that's the background of our tool. It's why I'm telling this to you. This domain-specific language is inspired by the recent works in the community regarding dataset documentations, allow describing datasets in a structured format, and that's the key point, a structured format. And why is useful a structured format? Because it allows us to build search and comparison engines, dataset comparison engines. It allows us to facilitate experiment replicability. We have a standard format or a structured format to annotate datasets. We can replicate the experiment if the data sources are not available. It's a common case in healthcare. And we can generate artifacts, documentation, code, and etc. I will show you an example right now. But first, let's ask the important questions. What can be annotated with the DSL? Is there a quick overview of what can be annotated with the tool? This is a quick overview of the DSL powering the tool. The first part is metadata at the top left. It's a quite classical way to describe data sets. We are looking at title, version, dates, description, licenses. Maybe applications is more domain specific. We are thinking about past applications, recommended applications, non-recommended applications, benchmarking, if it's a benchmark data set, and so on. And also at the deprecation policies. If the data set gets deprecated, what has to be done? The second part is composition. This part, it's easy to understand. I think it's the attribute, the structure of the data set, and all the relevant, it's the important word here, all the relevant statistical values and the consistency rules. We don't have to express all the statistical values. We, as the dataset creators, we can express only these meaningful statistical values. For instance, the balance of the labels. This dataset is labeled positive and negative, and this attribute is balanced. The distribution is equal. Or, for instance, age, the attribute age has to be higher than 0. That's a consistency rule. The last part is provenance. And provenance, conceptually, is all the process that have happened to create this data set. We are talking about gathering process, labeling process, also the pre-processes, screening the data or sampling the data. And all these processes are related with social issues. For instance, if a gathering process is only happens in one country, could be a geographical bias. To have an example of how this can be related. Okay. Now that we know what can be annotated with this tool, let's present the tool. It's DescribeML. It's open source. You can find our repo. It's a plugin for Visual Studio Code. It's quite different, but not Eclipse. It's implemented with Langium. It's a workbench to create DSLs in TypeScript, and Langium is developed by TypeFox, that are the guys who develop Xtext. That's a link with the Eclipse community. It's open source and published in the Visual Studio Code market. So you have a Visual Studio Code, you can go to extensions and tap DescribeML, and you can start using our tool. And it's a language plugin that implements modern language features as autocompletion, as syntax highlight, and so on, and some custom Visual Code extensions facilitates the documentation process. And demo time, because this is a demo. So let me show you. Okay. That's our tool. It's a Visual Code extension. And to demonstrate our tool, we're going to describe a dataset. That is the main goal of the tool, describing datasets. So let's make a trial and let's see how it works. This is it's Kaggle.com. It's a famous repository of datasets, and this is a video game ratings from IMDb. It's a very simple dataset. I think that will be a good starting point to use our tool or to highlight some of the features of our tool. So here is our tool, and let's start. The first step is to create a DescribeML file. Okay, we have created the file. It's an empty file, and starting from scratch could be difficult. No? So let's use our plotter data services. We have already downloaded our data. Here we have the data. It's a tabular data set with the title, the year, and the genre of the video games. So we're going to go here and search for our data. And this will generate a draft of our description file with some relevant information. It's some basic information. We are not doing reverse engineering to datasets right now. It's a future feature. But the important point here is that we have a structure. There are some basic information, for instance, the attributes of the dataset. But the important point, I repeat, is the structure. This structure guides dataset creators through the documentation process and answers the question, the difficult question of what have to be documented to have a good documentation of our datasets. And it's just filling up these concepts, you can have a good guide. So let's start video games dataset. But we don't have so much time, so I already have a completed description. And we are going to fill some points to see the future of the tool. Here is the complete description. We have looked at this website and extracted information from this website, and we have filled at all the concepts that we can. And here, for instance, they say task. The task this dataset is intended for. So let's select a task. I think that the task is classification. Maybe could be more tasks. These are licenses here also, and we can select some licenses the correct license, I think it's CC0 public domain. Here at line 17, there is a concept to say write standalone and write with model. If you are not familiar with the domain, maybe it sounds strange to you or difficult to understand. So let's look at the hints the tool provides. Standalone, choose the level of distribution of a standalone data. And write with model, write model, choose the level of distribution of models trained with the data. No, maybe it's clear to use these concepts. If we take a look to the composition part, we can see that we have the attributes and some description of the attributes. Here is a statistic of the title of the games, the count, the type categorical, and some statistics. Yeah, unique percentage, 90%. This is telling to us that 10% are duplicated in the data set. That could be interesting. Maybe we see the attribute rating. We have another example of statistics, rating of the games on a scale 1 to 10. And here we have some statistics we have extracted from the data, the mean, the standard deviation, the quartiles. That's quite interesting. But the most interesting part, it's directors. And why? It's only a description and account of the directors. Why this is interesting? Because I've been looking at the data set or at the data I've extracted as I'm the data set creator, and I've seen that maybe the majority of directors are men instead of women. I'm not sure, but I suspect that this could be a potential genre bias, and it's not easy to extract the genre of the name. So, which is the statistical value to express this? Okay, let's connect this attribute with the potential social issue. Here in the social constants part, let's create a new social issue. Social issue, let's say genre bias. It's an issue type of type bias. A description, potential bias in directors. Okay. And let's relate this bias with the specific attributes. Okay. In an easy manner, we have annotated our data set with relevant data and with a high level analysis. And that's the powerful of the tool. It's not annotating statistical values that can be relevant, but also connecting these statistical values and the attributes with some high level analysis, some qualitative analysis that people who are creating the data set can write. Okay, so let's back to the presentation. That's me presenting the tool. Okay. Conclusions and future work. Conclusions. It was a demonstration. We have demonstrated our tool. Future work. We plan to port our tool as a standalone web component in the web browser. We have seen in the validation process that we are performing right now that the main difficulty of using our tool is Visual Studio Code, the platform. So let's extract the tool from the platform, and we plan to port this tool as a standalone web component, so you can only access to a URL and start editing or start documenting your own. The second point is extend. We plan to extend the DSL and the tool, obviously, to adapt other elements of the machine learning pipeline. For instance, if we get the output of the models, the machine learning models, we can calculate fairness metrics. I think there is a paper presenting right now in another room who have a DSL for calculating these DSL models. I have to talk with the author. And the third one is integrate. And that's more complicated, maybe. It's integrate the description artifact, the document we are creating, the DescribeML, with the data production pipeline. And what's this? We don't think that the reality of data-intensive apps will be that I have my big data set, and after I have my data set, I have to document the data set. That's not the reality. In a big data production pipeline, the documentation is created in every stage. In the conceptualization stage, in the gathering, in the labeling, and we plan to adapt our tool to be useful in every stage and to create this documentation in these different states of data production pipelines. And in that way, we can use our description artifact also as a accountability artifact that could be okay, and also as artifacts of transparency. And that's it. Thank you. This is our contact. Feel free to ask questions. If you are so shy, you can speak later at the room. Thank you.